Ladies and gentlemen, today is the day we're going to talk about monads. I'm going to show you how to abstract away side effects to a degree that you would have never dreamed possible in your wildest nightmares. And today we're going to introduce the most amazing syntax ever. And you don't need a PhD in astrophysics in order to understand this stuff. And after watching this, you're going to be one step closer to being a 1970s compiler optimizer. And it's going to be really easy to migrate your code without any extra effort. And after watching this, you're going to have the cleanest code base ever. You're going to be able to pass a piece of data into a class called Partition, which is an instance of monad. And you're going to be able to unlock a new syntax that allows you to chain functions that have some kind of criterion for when they should apply or not. So for example, I've defined this function on positives here, and that basically allows me to turn any other function into a different one that I can apply onto the data set only when the predicate that is like latent or underlying, or that I have defined to apply here, to be valid. So in the case of on positives, you can see that I got my data here, and if I just run my script here, you can see that this set or list has been divided into two parts. So the partition of value and error, and the value part is going to contain the result of applying the function on each value in my set when it was successful. But if something in that computation went wrong, it's going to be stored in error. And one of the big benefits of that is that you're basically going to be able to define your side effect handling, or the way that you want to communicate those errors, or log them, or store them, or push them to the front end when something went wrong, only once. So you basically would have to, but that's what we're going to do in the next video, extend this class. You're able to chain this syntax repeatedly. So for example, in this case, I've just used a left associative magic method, in this case the OR operator, and I've defined that to be equivalent to the bind method. And so the bind method, it's a bit of an adaptation of a function that we implemented before, or a class method that we implemented before, called fmap. And this is basically just a special kind of application where we're applying the function on the right to the wrapped value inside the result. But this time, this function that we're having, it's a special function that is again itself returning an instance of that same monad. So let's look at the implementation, and before we're going to look at partition, we're first going to look at the monad itself. So in the previous video I defined the functor, and in between functor and monad there is another concept called applicative, which implements this function apply, but we're not going to go into detail here. So let's take a look at this monad class. So just maybe as a reminder, if you look at the functor, it implemented two methods, unit and fmap. The unit just allowed us to instantiate an object of the functor, and then the fmap allowed us to apply some function to the wrapped value. So now if I look at the implementation of my monad, it has a very similar concept. I have a bind method here, so you can imagine this is a special kind of fmap, and here instead of returning a new wrapped value, it's just going to apply this function to the result as a basic framework. And this bind method can be different for different kinds of monads. Here I've bound this OR magic method to bind, so that I can unlock my special syntax of being able to indefinitely chain operations. So okay, and then we have the implementation of our partition, which is just an instance of monad, but with the special adaptation that it now has two attributes, value and error, which are going to carry this these lists that are like subdivisions of the original value that we're going to pass in there. Okay, so let's look at the implementation. So here we have our bind method, and this method has the same type signature. And that means that we need to apply a little bit of custom logic here in order to basically flatten out our result. So what I've done is I've said, okay, I'm going to have some function f that is going to produce a new partition, and then we're using a sum here to basically concatenate all the results together. We'll define an add method for our partition, so we can just use sum here. And so what the add method is doing, it's very straightforward. As you would expect, it will put the values together and the errors together. So if this is a list, it will just concatenate. So just to illustrate the point, if I have two partitions here and I want to add them together, then you can see that the final result will have put the errors and the values together in one box. And just to illustrate the result, what the bind method does, you can pass some kind of function that produces a partition from the wrapped value, and in this case only the value itself. So as you can see, we're iterating over self.value here and not the error. then it will produce a new partition. So here you can see that it put the one from the value of the first partition into X, and then it produced a new partition for the final result. You know, here's the thing. I am defining these abstractions so that I have to think less in the future and not more, right? So we want to find some kind of way in order to produce these special partition functions from normal functions. I've defined this function result here that is going to be a decorator that you can put on functions that is basically going to only apply some kind of function f that you decorate with it when it can apply that, and when it's not able to, it's just going to put the argument inside the error stream of the partition. So this function result, it will take some kind of function from t to u, and it will be able to basically upgrade any function into this special partition function. Okay, and so why is this so amazingly useful? It's because this result decorator is basically modifying the behavior of existing programs that can fail, right? That can have exceptions in such a way that it's going to turn those exceptions maybe into like actual error values. Instead of something that breaks the program, it becomes something tangible that we can work with. Okay, so let's see how this works in practice. I define my function onPositives here, where I'm basically saying, okay, when my assert statement fails, then I'm going to return the partition with the original argument x inside my error stream. But if it didn't fail, it's just going to go on and it's going to return the final result of my computation, namely with the original function here applied. Right, so this onPositives is basically like a kind of filter where if I pass some kind of function that's going to add 1 to maybe some kind of number and I wrap it in onPositives, then this whole thing here is basically going to be an upgraded version that will return a partition instead. So in this case, let's see what this returns, and you can see that when the value that I put in here is bigger than 1, is going to create a partition with the new value in the value field of the partition. But if I ran it with something that didn't meet the mark, then it would be in the error field. And so now you might appreciate why we went through a little bit of extra work to define such a complicated bind method here, because you can see how extremely easy and elegant it is to define this function onPositives. I mean, this is just literally a function that you would use normally in a normal piece of code, right? Like it could be a server that you're running, you could be sending some request that can fail. When it fails, you might throw an exception. So maybe you already have a lot of functions like this that can just simply fail. And you want to start tracing and tracking errors in some kind of structured way without rewriting your entire code base. Well, so all you would really need to do in order to get this superpower of being able to chain these partitions together and these results that can fail and abstracting away later those side effects, allowing you to log and communicate in a really structured way, basically only by adding one single decorator. That's all I had to say. I hope you feel enlightened now.
You there! Like this video and subscribe right this instant!